Okay, so I want to take a look at this system of linear equations and look at solving it. So yesterday what we were looking at is we were looking at the method of substitution. So with the method of substitution, what do I have to do with this question? What was the pattern? What was the rule?
You have to have one variable.
So I have to isolate a variable. So which equation do we want to start with, the first or the second? Okay, so what variable do you want to isolate, the x or the y? Okay, so 2x will equal negative 4y plus 7. And then what do you want to do? Divide by 2. So x equals negative 4 halves y plus 7 halves. Instead of negative 4 halves, what can I write?
Negative 2.
So negative 2y plus 7 halves. And then I have to put that into x in the second equation. So 4 times negative 2y plus 7 halves, this still didn't work the way that I wanted it to, minus 3y equals 3. So I multiply this through, I get negative 8y plus 28 halves, which is
14.
minus 3y equals 3. I get negative 11y plus 14 equals 3. Negative 11y equals negative 11. Y equals 1. And then I can plug that back into my other equation. X equals negative 2 times 1 plus 7 halves. So that becomes negative 2 plus 7 halves.
Pardon the interruption. If there are any more hot lunch orders for pizza especially, please bring them to the Lerman Commons immediately. Thank you.
I would get 3 halves. Because it would be negative 4 halves plus 7 halves. So I'd get 3 halves for my x value. What is the one problem that comes up when you're doing this question that we have to contend with?
Fractions.
Fractions. Fractions are not great to work with. In this case, it wasn't the best example I could have taken because this ended up being negative 2, a whole number. And really, 7 halves is a decimal, is 3 1/2, which would have made it easy. I could have moved them to decimals. But sometimes the fractions that you get, you can't write as a decimal. If that had been 7/3, I wouldn't have been able to write that as a decimal because it's a repeating decimal. So another system of solving for these types of equations needs to be determined. We have the method of substitution, and I said yesterday substitution works the best when you have a coefficient equal to 1 because it's easy to isolate and then it's easy to then substitute. What we're going to look at today is we're going to look at what happens if I don't have coefficients of 1. Is there another system? And the answer to that is yes, there is. That system is called elimination. So again, I'm going to skip the steps and I'm going to walk you through the first example. So we have a system of equations where the first equation is 2x plus 7y equals 13. And the second equation is 3x minus 7y equals 2. Well, if I looked at the two equations and I treated them like polynomials and I added them together, if I have 2 x's and I add that to 3 x's, I will now have 5 x's. If I have 7 y's and I add negative 7 y's, I will now have
No y.
I'll have no y's. So I don't even have to write the y in there. And then if I have 13 and I add 2, I eliminated the y's. Which is why the title of this section is Solving Systems of Equations by Elimination. You eliminate one of your variables through addition or through subtraction. So now I have 5x equals 15. So what would x equal? 3. So now that I have x is equal to 3, I can put it back into the equation and solve for y. So I can pick either equation. I'm going to pick the top one. 2 times 3 plus 7y equals 13. 2 times 3 is, so 6 plus 7y equals 13. I want the 7y isolated, so I need to get rid of the 6. So what do? Subtract 6 on both sides, and 7y would equal 13 minus 6, 7. So if 7y equals 7, what does 1y equal? 1. So there's my solution to my system. X is equal to 3 and y is equal to 1. So I can verify the solution satisfies both equations by substituting it in. 2 times 3 plus 7 times 1. So 2 times 3 is 7 times 1. And what's 6 plus 7? And the two sides match up. So there's one equation satisfied. Do the same for the other equation. 3 times 2, which is 6, minus 7 times 1, right? Or sorry, not 3 times 3. 3 times 3, there we go. 3 times 3, which is 9. 9 minus 7 is, does that equal the other side? Yes. So now if you look at the flow chart that's at the top, we're going to skip step 1 for now. We're going to start with step 2, 3, and 4. Step 2 says add or subtract the two equations to eliminate one of the variables. So in this case here, I added them together to eliminate the y's. Then what you're going to have is you're going to solve the resulting equation to determine the variable of the value of one of the variables, and then you're going to substitute that solution into either one of the equations to solve for the remaining variable. So let's try that again with class example number 2. I have 2x plus 6y equals 6, and 2x plus 3y equals 4.5. Now, which variable makes sense to eliminate, the x's or the y's? Why the x's? Because they're the same, and I can do what, Isa?
Subtract both.
I can subtract them. Because if I take 2x and I subtract 2x, I get no x. I get 0 x's. And if I take 6y and I subtract 3y, I get 3y. And 6 minus 4.5? 1.5. And 1.5 divided by 3. 1/2. So we'll leave it as a decimal 0.5. And now I can determine the value of x by substituting y into one of those equations. Would you want to substitute y into the first equation or the second?
First.
Why?
Because you're not dealing with a decimal.
Yeah. Because if I take 6 and I multiply it by 1/2, I'm going to get 3. Whereas if I take 3 and multiply it by 1/2, I'm going to get 1.5. So I'm going to have decimals to deal with. So 2x plus 6 times 0.5 is supposed to be equal to 6. So I get 2x plus 3 equals 6. Subtract by 3 on both sides. And then divide by 2. And I get that x is 3/2 or 1.5. And then again, I can verify the solutions by plugging those values of x and y into the original equations. So 2 times 1.5. What is 2 times 1.5? 3. And then 6 times half is, what's 6 times 0.5? And what's 3 plus 3? And does that equal the right-hand side of the equation? Yes, so that's verified. And then if I do the same with the other one, 2 times 1.5, which is 3, plus what's 3 times 0.5? And what's 3 plus 1.5? Which equals the left-hand side. Okay? So I'm going to give you about 5 or 7 minutes, and I want you to do questions 1B and 2B. So let's take a look at class example number 3. If I look at this system of equations, if I add or subtract the 2 equations together, will I be able to eliminate the variables? Why not? What is the reason why I can't eliminate the variables right now by adding and subtracting them? I don't have common coefficients. I need common coefficients in order to be able to eliminate them. So does adding or subtracting the equations eliminate either of the variables? Nope. So take the second equation and multiply it by 3. If I multiply the second equation by 3, what do I get?
12x minus 3y.
Equals,
66.
and then I have 2x plus 3y equals 4. Now if I add them together, 2x's and 12x's give me, and the y's will become eliminated because I've got a positive and a negative. And 66 plus 4, and what is 70 divided by 14? So I get x is equal to 5. Put that back up into one of my 2 equations. So 2 times 5 plus 3 times 4. What's 2 times 5? 10 plus 3y equals 4. So I subtract 10 on each side. And 3y equals, and then y would equal -2. So there's the solution to my system. So if I verify this, I've got 2 times 5 plus 3 times -2. What's 2 times 5? And 3 times -2? And what is 10 plus -6? And does that equal the right side? Yes, it does. If I look at the second one, I've got 4 times 5 minus -2. So 4 times 5 is 20. And the minus -2 becomes +2, which equals 22, which is also equal to the right side. So I've verified the solution. If I go back to my original system, 2x plus 3y equals 4, and 4x minus y equals 22. Instead of multiplying the second equation by 3, could I multiply the first equation by an appropriate number that I could then use elimination for?
2.
Why 2?
Because 2x times 2 would be 4x.
And then I would have my 4x minus y equals 22. And then would I add these or would I subtract them? I would subtract them. And something you may have noticed when I'm doing these, I circle the operation that I'm using, that I'm adding, so that it's a reminder to me. So circling the operation is a reminder of what you're doing, because you're subtracting the second equation from the first equation, so that you're eliminating your x's, but you're also remembering that you're subtracting by a negative y, which is why you get a 7y. And then you're subtracting the 22 so that you get a negative 14. So then y becomes negative 2, and then you can do the same process that you did before. One other thing to think about, and all of you can listen to this, when you're picking which one that you want to eliminate, if you find it easier to add, whenever you have coefficients that are the same sign, pick those ones to eliminate. So if I go to the one example that I had right, I think it was with this one right here. If I had chosen to eliminate my y's instead of my x's, I would have added the two equations together, because I would have gotten a positive 10y and a negative 10y, and then I could simply add. And sometimes we find it easier to add than to subtract, because those negatives give us problems. So that's something to consider when you're going through your elimination. Okay, so again, if you pick the variable that you want to eliminate, so in this case, we're actually told, eliminate the variable b. Look at my two coefficients for b. I have a 3 and a 7. What's a common multiple of 3 and 7? 21. So to get to 21, what do I multiply the first equation by? 7. So if I multiply the first equation by 7, I will get 35a plus 21b equals 21. And what would I multiply the second equation by?
Negative 3.
Does it need to be a negative 3, or can it just be 3? If I make it just 3, what's 81 times 3? 243. Now that I have these two equations, would I add the equations or would I subtract them? I would add them, because these two have different signs. So when the signs are different, add the equations. When the signs are the same, subtract them. Okay, so I'm going to give you a couple minutes. I want you to finish this off and tell me what you get for a solution. Okay, so let's finish this up. If I add these together, I'm going to get 44a. I no longer have a b variable, and I get 264. Divide both sides by 44, and what does a equal? 6. And then I can put a into either one of those two equations. 5 times 6 plus 3 times b equals 3. So I get 30 plus 3b equals 3, not 30. Subtract by 30 on each side. 3b equals negative 27. Divide, and I get negative 9. Okay? And I could repeat the process instead. And I could decide that I want to eliminate my a values. So if I wanted to eliminate my a's, what would I multiply the first equation by? 3. Because what am I trying to get my a's up to? 15. Okay? So if I multiply the first equation by 3, I get 15a plus 9b equals 9. I multiply the second equation by 5, and I get 15a minus 35b equals 405. And then this operation here this time is subtraction. So when I go to subtract these, 15 minus 15 is 0. 9 minus negative 35 becomes a positive 44b. And then 9 minus 405 becomes negative 396. Which when I divide by 44 gives me negative 9. And then I would repeat what I did before, take that negative 9, put it into one of the equations. So 5a plus 3 times negative 9 is supposed to be equal to 3. I get 5a minus 27 equals 3. Add 27 to each side, and 5a equals 30. Divide by 5, and I get that a equals 6. So I will still get the same solution either way. Okay? So the method of elimination is really useful when you have coefficients in front of all your variables. So the question always comes up, when do you use substitution? When do you use elimination? You could use elimination all the time, but you might find substitution a bit quicker, especially if one of your coefficients is already equal to 1. Okay? So I have 2 more examples to go through. Solve the following equation using elimination. So before I get started with this question, what would I want to do first? How do you mean by change the equation, Kate? Change to general form. Or maybe even change it so that this becomes 4x plus 2y is equal to 13. And then this one would be 3x minus 5y equals 26. I want them to be written kind of in similar formats. Now, give me a variable you want to eliminate, x or y?
X.
X. So if I want to eliminate my x's, what do I have to multiply them both by? Or what common coefficient will they need then? 12. So if I know my coefficient has to be 12, to go from 4 to 12 I would multiply by, so I get 12x plus 6y equals 39. And the 3x minus 5y equals 26, I would have to multiply by 4. So then I get 12x minus 20y equals 26 times 4 is
130.
What operation allows me to eliminate? Subtraction. And when I subtract these, I get 6 minus a negative 20, which gives me 26. 39 minus 104 equals,
Negative 65.
and what is 65 divided by 26? Is it a decimal? Negative 2.5? And because it's a terminating decimal, you can leave it in decimal form rather than changing it to a fraction. And then I can put that back into one of my 2 original equations. Doesn't really matter which one I pick. If I pick the second one, I get 3x equals 5 times negative 2.5 plus 26. What is 5 times negative 2.5? Negative 12.5. And what's negative 12.5 plus 26? $13.5. And what's 13.5 divided by 3? And there's my solution. Okay. So what's the first thought in your head when you look at question number 6? What's that, Delana? Confusing. Why is it confusing? Fractions. So the first thing that we're going to do is we're going to deal with these fractions. Before we even start looking at solving this by elimination, we're going to get rid of the fractions. So to get rid of the fractions, we look at what is a common denominator for the fractions that we have. So my denominators are 3, 5, and what would the denominator over 2 be? 1. So what's my common denominator for 3 and 5? 15. So what I'm going to do is I'm going to multiply every single term by 15. And this over, or this line here, what operation does that mean? Divide. So if I have 15 on the top and 3 on the bottom, think of this as being 15 divided by 3 is 5. So I now have 5 times x minus 2. No fraction left. 15 divided by 5. 3. So now I have 3 times y plus 2 equals 2. So take a moment and clean it up. Remove the brackets. Yeah, so it should be equal to 30, not 2, because I forgot to multiply it by 15.
No, it's positive because if I just input what that is negative, then they would times.
So when I go to remove the brackets, I get 5x minus 10. Think of this as a negative 3. So I get a negative 3y and a negative 6. So I get 5x minus 3y, combine the negative 10 and negative 6 to give me negative 16. Move it to the other side by adding, and I get 5x minus 3y equals 46. If I look at the second equation, my denominators in the second equation are 5 and 2. So what's my common denominator? 10. So I'm going to multiply each term by 10. And again, I'm going to use this dividing sign as my helper. Because instead of having to go 10 times all of this divided by 5, I'm going to skip that and just look at what's 10 divided by 5. 2. And then take the 2 and multiply it by the 3. 6. So I get 6 times x plus 1. Which would be the same as going 10 times 3 is 30 divided by 5 is 6. Okay? If I do the next one, 10 divided by 5 is times 4. So I get negative 8 times y minus 3. And then the last one, 10 divided by 2 times 21. And then we'll clean this up by removing the brackets. So I'll give you a couple of minutes to do that again. Okay, so when I remove the brackets this time, I've got 6x plus 6 minus 8y plus 24 equals 105. 6x minus 8y plus 30 equals 105. So now I've got 6x minus 8y equals 75. All I've done to this point is I've just eliminated the fractions. Now I have 2 equations that I can then try to use my process of elimination to solve. So I need to pick one of these that I want to solve, want to eliminate, either the x or the y. Doesn't really matter which one you pick, you just find one. So if I chose to eliminate the x's, I've got a 5x and a 6x. What would be my common coefficient for them? 30. So I would multiply this first one by by 6. So I get 30x minus 18y equals, what's 46 times 6?
276.
And then I would do the same thing with the next one. I'd multiply it by 5, and I get 30x minus 40y equals,
274.
thank you. And then to eliminate my 30x's, I would subtract them. So 18 minus negative 40 becomes 22. 276 minus 375 is 99, right? Negative 99, sorry. And then when I divide them, I get negative 99 over 22, which is negative 9 halves. And then I put the negative 9. So when you put the negative 9 halves back into the equation, negative 8 times negative 9 halves gives me a positive. 8 divided by 2 is 4, times 9 is 36. Subtract by 36 on both sides and I get 39. Divide by 6 and I get 39 over 6, which reduces down to 3 halves. And there are your questions to work on.